All right, so last time, if you remember, what we did was we looked at equations in two variables, right? You know, equations in x and y. And we also saw what solutions to those equations are. They're not going to be just numbers, they're going to be ordered pairs. Okay? So you're going to have an ordered pair that's a solution. It's not just like in 1.1 where, you know, if you have an equation in one variable, the solution is a number. Here, we're kicking it up a notch, so to say. And then we have this concept of the graph of an equation. Basically, it's just the the graph of an equation in two variables. It's just the plot of all these solutions. That's all. That's just what it is by definition. It's the plot of all the solutions. Okay? Again, that's just what it is. So I guess kind of an example and something new. We have the graph of y equals a quadratic, that is a polynomial of degree 2. The graph of that is all solutions to this equation. And the graph for this is actually called a parabola. Okay, it's actually called a parabola. And it kind of looks like the graph of y equals x squared. In fact, you know what? Let me show you guys. I'm pretty confident I graphed y equals x squared last time, but I feel better graphing that though, just to be on the safe side. Let me just quickly show you. Okay. Just graphing it in decimals. Here we go. Good. Okay, now let me share that. Just going to share in decimals real quickly. Yep, there we go. Here we go. Yeah, so I just graph y equals x squared. That's all. You know, again, it looks like this. It looks like this, and a parabola. That's actually going to be some variation of this. You know, it might be shifted to the left, to the right, up or down. It might be, how do I say this? Flipped. You know, or I guess if you want inverted, but that's what a parabola looks like, something like this. All right, so that, again, this is decimals, you know. I think I've told you about decimals before. It's actually, you can actually download it as an app on your smartphone. You know, if you want to, you don't have to, but you can. I mean, I have it on mine and I really like it. So let me get back to the other screen. Let me get back to the notes. Here we go. I mean, I am pretty confident I graphed that last time or some time ago, but I just felt better showing it again. All right. Anyway, let's keep going with this. We also saw the x and the y-intercepts. The x and the y-intercepts, basically, again, of a graph of an equation in two variables. Remember, to get the x-intercept, you set y equal to 0 and solve for x. And to get the y-intercept, you set x to be 0 and solve for y. Okay, that's just what you do by definition. That's what the x and y-intercepts are. And also, we saw circles. In particular, we have the standard form of an equation of a circle. If you have a circle that has a center hk and a radius r, you know, little r is a positive number, the circle with center hk and radius r, it's going to be the graph of this. It's the graph of this equation. And again, it's all the points that are r units from in the Cartesian plane from this point hk. So it's all the points it's all the points in the Cartesian plane whose distance from hk is r. That's just what a circle is by definition. That's what the circle is by definition. This equation, you can actually derive it using the distance formula. Okay? You can actually derive it from the distance formula. Again, any point x, y on the circle has to be r units from this point, from the center. So that's just what you do. This was a graph also I presented last time. This was I think it's called the hyperbola. It's y equals 1 over x. Notice that it never crosses the x or the y axis. In other words, it does not have an x-intercept nor a y-intercept. Mostly because you can't set x to be 0 and you can't set y to be 0. I mean, if you set x to be 0, you have 1 over 0, and that doesn't make sense. If you set y to be 0, then you're looking for x such that 1 over x is 0, but there is no x that pulls that off. So this never crosses the x or the y axis. I mean, it's not the only graph that does that. You can easily draw another graph that never intersects the x or the y axis. Okay, now here's a new graph. Y equals the square root of x. The graph of this is here. I mean, I'm hoping that picture is good enough for you to see. I mean, I guess I could have made it a little bit lighter, but this is what the graph looks like. It's blue. So every ordered pair that is a solution of this equation is on this blue line. Okay. I mean, what's nice with technology today is, I guess in a sense, you don't have to memorize what the graph of this looks like. You can graph it easily, you know, using a graphing calculator, using a Desmos app in your phone, that kind of thing. I mean, it still wouldn't hurt to know what the graph looks like. So, all right. So this is just another example with graphing. Namely here, namely here, what we're doing is we're making a rough sketch of, we're sketching the graph of this equation. Sorry, I was messing up my words. So we're sketching a graph of this equation, right? And again, this is called the parabola because we have y equals a polynomial in degree 2. We have y equals a polynomial of degree 2. Now, yes, you can use a graphing calculator to graph it, or Desmos, but later on, we're going to see better, more efficient ways to graph it. Really fun ways we'll see to graph it. We'll actually graph what's called a quadratic function in Chapter 3. For now, all we can do is this. We can just choose some x values that you can plug in for x and get a reasonable y. That is, get a number y. And we do that, and we plot the corresponding points. Okay. So again, here, I just put the comma in the bottom point. So what are we doing again? Well, we choose x. So I chose x to be -2, -1, 0, 1, and 2. So for -2, okay, we replace x by -2, as you can see. We calculate the corresponding y value, okay? And here we get 6. So -2, 6 is a point on the graph of this. Normally, we would plot that point. I mean, I have the graph sketched already, but normally you would plot that point. And then we did the same thing with -1. That is, we take x to be -1. We plug it in for x, get the corresponding y, get the point, and plot it. Same thing for 0, same thing for 1, same thing for 2. You plug each x value in here, you get the corresponding y value, and then you get the corresponding point and you plot it. The x values here, if I were to ask you to do this on an exam or quiz, I would give you the x values. I would give that to you. Okay. But again, this is a parabola because it's the graph of y equals a quadratic. And notice we also found a the y-intercept, right? We set x to be 0, and we got -2. That's where the graph crosses the y-axis, the vertical axis. The x-intercepts, we could get those. I mean, we don't have them here, but that would take a little bit more work to find. Okay. And that actually would be these two numbers. I mean, if we were to get those, we would probably have to use the quadratic formula, or we would have to factor. In other words, we would have to use what we know from 1.2. Okay, that's good. Okay, so this example, I actually have you calculate the x and y intercepts for the graph of this. I mean, you might know what the graph of this looks like. I mean, you could graph it in Desmos, but let's have fun and not graph it and calculate it algebraically. So I want everyone to take a minute or two to find the x and y intercepts of the graph of this algebraically. So in other words, again, for the x-intercept, you set y to be 0, and you find x. For the y-intercept, you set x to be 0, and you find y. You're setting the other variable equal to 0. So x-intercept, y is 0. Y-intercept, x is 0. So I want everyone to take a minute or two to find those now. Okay.